Good afternoon, pre-calculus students. Welcome back to Mr. Chen's channel. So welcome back to my master class. And this one will talk about the linear system equations for chapter 9 along with matrices. So today we'll start with 9.1. And as you can see that this one is section 7.1. It's the one that I generated from the different textbook. Okay, so you'll see that some of the problem here. It's about the system equation with linear and the non-linear. So solve each system, clearly show that the step taken to arrive at its solution. If none, say no intersection. So we'll try some of the problem here. So one problem at a time. So let's do A and B. Okay, so solve for x and y. So going back to what you did in Algebra 1, Algebra 2. So the way to solve for a system equation. So we do have two special techniques. So one is called the substitution, and the other one is called the linear combination or elimination. Okay, so we'll see which one is easier to apply. So the first one, as you can see that the equation here is given with that nonlinear and linear. So it's easier to apply the substitution technique. So for the first equation, so we want to start it off with the replacement of that y. So instead of using y, we're using x. So 1 over x squared. So plus 1 over x squared. So that equals 1 half. So combine the like term. We do have 2 over x squared equals 1 half. And then cross multiply. So we do have x squared equals 4. Okay, cross multiply. And then solve for x by taking the square root both sides. So we do have x equals plus minus 2. And then step 2. So you want to solve for y. So if x equals 2, so that means y equals 2, using the second equation. If x equals negative 2, that means y equals negative 2. But don't forget, rewrite it with the xy coordinate form, so it's 2 comma 2. And then the other one, it's negative 2 comma negative 2. And now what about for b? Quite similar, so using that the substitution, or you can use the elimination, but it's easier to apply the substitution. So set y equals xy squared minus 2 for the second equation. Okay, so once you set it like this, and then back to the first equation, so what we got is xy squared minus x squared y equals 2. So this one, if you don't want to deal with that y, we can always put it out. So take out that y. Before you take that out, let's just put in the replacement. Okay, so the replacement. So y equals xy squared minus 2. So what we found here, so x times xy squared minus 2. Then that would be just like more variable involved. So instead of using that the substitution technique for this one, so let's apply that the elimination or the linear combination technique. Okay, so let's try to do it that way, see what happens. So first thing that you want to do, you want to line up the equation with xy, xy. And also this one, since we do know that they're both equal to 2, so we can set it equal to each other. So that's another way you can do it. So xy squared minus x squared y equals xy squared minus y, because they're both equal to 2. Okay, so this one, xy squared got canceled because we got both of those on the left side, the right hand side. So what's left here is just negative x squared y equals negative y. And a lot of people thought that y, we can cancel out the y. But please don't do that, because you can cancel out one of the possible solution. So what we want to do, we want to bring everything together. So it's y minus x squared y equals 0. And then factor, take out the greatest common factor, y. So we got 1 minus x squared. So that means y equals 0. And then 1 minus x squared equals 0. So solve for x. So 1 equals x squared. So x could be plus minus 1. So once we solve for all the possible independent solutions, again, the one that we found here, so they're just considered the independent solution. They're not the final solution yet. So what we need to do, we need to verify them. So when x equals 1, so we need to solve for y. So one thing that we notice, so y equals xy squared minus 2, but just plugging back to the second equation instead of isolating the variable. So when x equals 1, so put it back to the second equation. So we do have 1 y squared minus y equals 2. So bring everything together to one side and then factor. So we got y equals 2 and y equals negative 1. So what that means is that when x equals 1, y could be 2, and also y could be negative 1. And then what about for the other possible solutions? So let's say x equals 1. So when x equals negative 1. So plugging a number back here, so we do have negative y squared minus y equals 2. Back to the second equation. So what we found here, we got y squared plus y plus 2 equals 0. And then this one is non-factorable. And also, if you try to solve for y here, you'll get the imaginary solution. And how do I know that's imaginary? It's because the discriminant. The way to find the discriminant, b squared minus 4ac, if you find out that's less than 0, that means there's no real solution. If there's no real solutions, so that means there's no need to deal with that, the xy coordinate for this one. So b squared, so what we got, it's 1 squared minus 4 times a times 1 times 2. So what we found here, it's negative 7, which is less than 0, so that means there's no real solution for this one. So that means for x equals negative 1, no need to worry about that. And what about y equals 0? If y equals 0, what happened with the equation here for the second equation? So x 0 squared times x, or x times 0 squared. So step, step 4. So verify that y equals 0. So back to the second equation. So what we found here, so we do have x times 0 y squared, or 0 squared, minus 0 equals 2. Well, the thing is that it's impossible to have 0 equals 2. It doesn't make sense. So there's no solution for this. So the only solution that we found would be 1 comma 2, and then 1 comma negative 1. Okay, so now going back to the template, let's see what else that we have for solving the system. So some of those, you see that it's like a conics, okay, it's conics. So ellipse, and then the other one's a parabola. Another way to verify that, you can always sketch the graph to find out the point where they intersect. And then let's do D. Let's do D and E. Okay, so for D and E. Okay, so for D, we do know that y equals 2 secant x, y equals 2 cosine of 2x. So this one, again, set that 2 secant of x equals 2 cosine of 2x. And using the trig identity, we do know that cosine of 2x is considered 2 cosine square of x minus 1. And then 2 secant of x is written as 2 over cosine of x. So just rewrite everything in terms of cosine of x. It's a rational, the other one is a quadratic. So in order to get rid of the denominator, we multiply both sides by cosine of x. So we got 2 equals 4 cosine cube x minus distribute, so 2 cosine of x. And then bring everything together, so we got 4 cosine cube x minus 2 cosine x minus 2, so that equals 0. And as you can see that this one here, so this one is a nonlinear, it's a cubic trinomial. So let's just replace that cosine of x by w. So this one is written as 4w to the power of 3 minus 2w minus 2 equals 0. Non-factorable, so we're using that p over q, rational 0 theorem. So what we found here, so it looks like it's going to be negative 2 over 4. But the thing is that we can always take out the 2 or divide everything by 2. So we do have 2w to the power of 3 minus w minus 1 equals 0. Again, divided by 2, divided by 2. So that means p over q is 1 over 2. So list all the possible factor, plus minus 1, comma, plus minus 2. So the possible 0, we do have plus minus 1 half. Okay, so from here, so using the synthetic division, okay, let's just put in step 1, isolating that, and then step 2, making it as a polynomial. Okay, so step 3. So using the synthetic division to find out the actual 0. So what we found here, so we got 2. 0 w squared is missing, so 0. Negative 1, negative 1. So let's start it with the first attempt. Let's say w is 1. So 2, bring it down. 2 times 1, 2. Bring down that 2. And then 2 times 1, 2. Plus negative 1, so it's 1 times 1, 1. Final remainder, 0. So that means this one is written as w minus 1. 2w squared plus 2w plus 1. So the whole thing, that equals 0. So what this one is saying, that w equals 1. And then if you try to solve for w here, we try to use the quadratic formula, but you end up with the imaginary number. Again, the reason why that I do know, because the discriminant, it's less than 0. So verify that b squared minus 4ac, would that be less than 0? So 2 squared minus 4 times a times 2 times 1. So 4 minus 8, it's negative 4, which is less than 0. So no need to verify that. So it's only w equals 1. And then finally, isolate that w. So what we got here, unsubstitute. So we do have cosine of, well, w equals cosine of x equals 1. And we do know the restriction for x is from 0 to 2 pi. So they're both included. So that means x could be either 0 or 2 pi, or both. And then once we solve for x, and then we just want to solve for y. So step 5, solve for y. So plugging a number back to the equation, so y equals 2 times secant of 0. So 2 times 1, then that'll be 2. So we got 0, comma 2. And what about if x equals 2 pi? Would that be the same y value? It is. So 2 times, well, 2 pi. So 2 times pi, 2 pi, secant of 2 pi, that's 1. 1 times 2, then that'll be 2. So this one would be considered 2 pi and comma 2. Okay, so we do have 2 points of intersections with the secant and the cosine of 2x functions. And now, what about for e? Okay, so let's check it out for e. So this one is natural log of x quantity squared minus natural log of x equals y. Okay, so one thing that we can do here, we can always solve for natural log of x first by using substitution. Again, give the number for the equation. So for the first thing that you want to do, so isolate that natural log of x in the second equation. So we do have 3 minus y. So going back to the first equation, so natural log of x is 3 minus y, quantity squared, minus natural log of 3, natural log of x, so it's 3 minus y, so that equals y. And now from here, we can solve for y first. So using substitution. Expand it, so 9 minus 6y plus y squared, minus 3 plus y. Bring all the y's together, so minus y here, 0. Rewrite it from the greatest power to the least. So we do have y squared. So negative 6y, 3y, negative y cancel, so minus 6y. And then plus 9, so that equals 0. And try to factor this one, so y minus 3, quantity squared, equals 0, so y equals 3. Again, y, what is that equal to? So one thing that we notice, so y, it's 3. So step 2, so solve for x. So plugging back to the second equation, so we do have 3 equals natural log of x plus y, so plus 3. So 3 minus 3 cancel, 0. So natural log of x. Take the base e on both sides. So that means x equals 1. Because natural log of 1, which is what? Natural log of 1, then that'd be 0. Okay, so 1 comma 3. Okay, so take the base e both sides, so you see that x equals 1. Okay, so checking the work, you want to check the work here, so just plug in a number back to the original equation. So natural log of 1, 0. Natural log of 1, 0. Wait, that doesn't make sense, right? So 0 minus 0, that cannot be 3. So this one you want to check your work as well, making sure that it's the valid solution. But it looks like it's going to fail the first equation. So natural log of 1, it is 0. Quantity square, 0. Natural log of 1, 0 again, cannot be 3. And then what about the second equation? Do we need to verify that? 3, natural log of 1, 0, plus 3. So for the second equation, it's valid, but for the first one, it's invalid. So therefore, the one we found, it's called the extraneous solution. So therefore, for the final conclusion, no solution. So gotta be very careful with the number that you find for the x and y, and then always plug in a number back there, the equation, first equation, second equations, to verify that. So one of the equation doesn't make sense, so that means the solution we found, it's extraneous. Okay, so now going back to the template, let's see what else that we got here, the word problem. So 2 rolling boat travels 144 miles downstream and back. Okay, the trip downstream took 3 hours, and the trip back took 8 hours. If that's back, that means going upstream against the current. Determine the speed of the current and the speed of the boat in still water. Okay, so this one is one of the classic linear system equation word problem. So how do we set up the equation for this? Okay, so here's what I'm going to show you next. So first thing that you always want to do, annotation, as always. If you guys see any kind of keyword, key number, guess what you have to do first? Underline it or circle them. So 144 mile downstream and back. So that's the total distance for downstream. So going downstream, that means half of the distance, then that'd be 72. And then going back 72 miles. And then for the time, it ticks. So 3 hours for going downstream, because that is going with the current. And then going back against the current, it takes a little bit more time, 8 hours. Okay, so one is downstream, but the other one back upstream. So one is going with the current, the other one is going against the current. So the speed of the current, we don't know what that is, x. The speed of the bow, we don't know what that is, so that's y. And here's another thing we can set up with. It's called the graphic organizer. So let's set up that, the rows in the column. So one is upstream, the other one is downstream. So let's put in the time. Okay, so the speed of the bow. The speed of the current. The time it takes. And then the distance. So the time it takes for going upstream, it shows that already. 8 hours. So it took a little bit more time because that is against the current. So the speed of the current against the current minus x. The speed of the bow, y. Speed of the bow is always y. And then speed of the current going downstream with the current plus x. The time it takes, 3 hours, less time. Distance, 72 miles. 72 miles. Put into unit as well, hour. So that means the speed of the bow and the current would be what? The unit, mile per hour. Okay, so this one is clearly setting up the equation. See the graphic organizer? The total speed times the time, it's always the distance. So for the first equation, y minus x times 8, so that equals 72. Second equation, y plus x times 3, So that equals 72. And then solve for x and y. So this one you want to distribute. So that means we do have ay minus ax equals 72. And then 3y plus 3x equals 72. Okay? And then the rest of this, so what we can do, find the least common multiples of 3 and 8. So least common multiple of 3 and 8, then that would be 24. So multiply the first equation by 3. Multiply the second equation by 8. So we got 24y minus 24x. So 3 times 72. So 216. And then over here, 24y. And then plus 24x. And then 8 times 72. 8 times 2, 16. 8 times 7, 56 plus 1, 57, 576. And then what we can do here, combine the equations together. So 48y, this one got canceled. So 216 plus 576, which is 792. Okay, so 792 divided by 48. Okay, so is that divisible? Okay, so 792 divided by 48. Okay, so it looks like it's not divisible. If that's not divisible, just leave it with a fraction. Okay, so once you solve for y, plug in the number back there and then solve for x. So making sure that I get everything correct here for the setup. Okay, so it looks good. Okay, so try to finish this one and then find out what that is for x and y. Okay, so that's it. So for the video that we have for the first part of the lecture, so this one, it's a system equation with linear and non-linear. Okay, so the next video we'll talk about the linear system equation with solution, no solution, or infinitely many solution, or finding that the multiple solution, or the value of k, or the possible value of a and b. Okay, so thank you for watching it. So I'll see you guys next time. Make sure that you guys subscribe to the channel. Click the little button right there. Okay, so you guys take care. Have a great one.